Good evening, everybody. Welcome to tonight's edition of Shop Talk, hosted by the Triangle Area SQL Server Users Group. So tonight, we've got a very special show because we have Tracy Baggiano. How you doing, Tracy?
Hello, I'm doing fine. How's everybody else? Not that
Tra-
they can answer, but
Even from a different remote location, we could say?
yeah, my living room.
Yeah, that's radically
It
different from...
looks better back here than my office, doesn't it?
And in addition, in another remote location, coming to us from the future as of 1955, Mike Christensen.
Hello, everyone.
It is a
Happy
very
Monday.
fancy backdrop you've got, though.
Very Mad Men.
Yes.
They spare no
it-
expense in the hospital industry.
There you go. In addition, special guest star, Chris Wood, who's going to interrogate me later on about Polybase. How are you, Chris?
Pretty good, Kevin. It's not too cold up here yet. I live in Edmonton, Alberta, Canada. So no snow yet.
No snow yet, but you could... Would you expect it in the next couple weeks?
Well, when our kids were younger, there was a 50-50 chance Halloween they'd be wearing a snowsuit under their costume.
Sounds about right. Because in the Midwest, it's usually like 30-40% chance, depending on where you go. So, all right, makes sense. So tonight, we're going to talk about the most important thing, which clearly is Polybase. But we also are going to talk about the next big announcement, which is day one of Past Summit. And yeah, I'm messing with everyone. We are going to talk about the SQL Server 2022 announcement. We're going to cover that in the latter section of the show, so stay tuned for that. But first, today was day one of the Past Data Community Summit. I had a chance to moderate a pre-con for Steph Locke. Steph was talking about the world of data science, introducing everybody to that from a high-level perspective. It was a rather interesting day worth of demos and training. Definitely worth the money. Tracy, you saw Rob talk about PowerShell and ARM templates and Bicep. Is that right?
Yeah. Well, you don't really use ARM templates with Bicep. Bicep replaces ARM templates.
True. And by the way, it's Rob Sewell.
Yeah, you should just give him more credit for it. Nobody knows who he is, or they have to go look it up themselves.
The DBA with a beard.
Yeah, then everybody knows that one. But yeah, it was very interesting. You know, our company gained some stuff to Azure this year, so I figured, that's automating, creating resources in Azure and a bunch of other stuff in Azure. So I would attend that one rather than Bob Ward's on migrating to Azure, because I'd actually managed to register for that one before it sold out. So I pulled out and had them release my seat so someone else could get into it, just in case somebody wondered. And went for Rob's instead, so that I could do the fancy automation stuff.
Yeah.
And it was pretty neat. He did like 5 minutes worth of slides, and then he spent the rest of the day in demos. So you just got to see him go through code, and then he had people had a special place to go ask questions. He didn't really have a moderator. He was kind of moderating himself. So he had a special little whiteboard. People could go in there and type questions and leave them behind. And he'd go in there and check them every now and then. So it was nice. And there's a lot of stuff you can do with Bicep. And I learned this new plugin for Visual Code that I like for my own presentations. So
Oh, which plugin is that?
Code Tour. You can set it up where it'll walk through your code, and you can make comments so that you can bring it up. And then when you share that code, people will be able to go through it and see the comments.
Ooh, I'm going to go check it out.
It was kind of neat. I was like, cool. And then you've got your notes too when you're walking people through the code.
Yeah. So that
It was kind of neat. So I was like, ooh, presenter tool.
Yep. So for folks who are interested, that is the Code Tour plugin for VS Code. And by the way, Anders is insulted that Rob Sewell is the DBA with the beard. But Anders, you cut your beard short too often, so I don't know. I think you need a
Rob
little
ever
more
cuts his,
commitment.
Anders. Yeah. Rob's is usually longer than his, name thing at well, no, every now and then he gets his name thing at Physical Summit longer, but his beard, pretty much matches, how long you can make those things. So,
Yep.
yours is, no offense, still shorter.
Yeah, although
Maybe,
Anders does have a good point that his beard is denser. So Rob's beard is not nearly as dense. That's true.
yeah, it's true. We can give you credits for that.
So all right. Tracy had that pre-con. Mike, did you attend any pre-cons for day one?
I didn't. I'm on mute.
Nope, you're not
Am
on
I
mute.
I did not. I did not attend any today. No.
Okay. Yeah, I ended up moderating Steph Locks, as I mentioned. That was definitely a worthwhile endeavor. Tomorrow, there's another day's worth of pre-cons. So some folks will be getting in on that. And then the actual conference sessions really begin Wednesday and Thursday, going on into Friday. So we've got a couple days of conference sessions ahead of us. And I figure there will probably be announcements, but I have zero insider knowledge. However,
Me either.
historically, what Microsoft has typically done, especially when Ignite preceded past Summit, is Ignite gets, hey, by the way, here's a new version of SQL Server. And then past Summit gets, hey, by the way, here's all the stuff that DBAs actually care about in the new version of SQL Server. But we'll talk about that a little bit more in a bit. First, though, Polybase. So Chris has been talking about Polybase, trying to get it working, and had a series of questions, and there were enough of them that it made sense to just have this be more like a Q&A session.
Okay, here's my situation. We have a bunch of data. I'm currently working at a university here in Alberta. I only work part-time, so I don't really know the full inside of this, but we have data in PeopleSoft, which then gets dumped into database S in server S, and then ETL comes along, looks at that data and populates database A in server S. We then use SSIS to push that data to server P, database A, where it's used to be reported on. A bunch of these SSIS take a long time because there's a whole bunch of indexes. So when you move it from one server to another, everything gets fragmented and it takes a long time. So I know when we went to 2019, when we were on CU11, there was some testing of trying to look at the data in Oracle, but I don't know details of that, and I don't really know how far it got, but it sounds like performance wasn't very good. So I'm thinking, rather than use SSIS, we can use Polybase SQL. So I've done a little bit of testing. I've created external tables on a server that looks back at another server, the same table, and pulls the information over. My original questions would have been, what are good and what are bad scenarios, i.e., we've got some tables with 50,000 rows, we've got some with 50 million rows. Is Polybase good for small tables, large tables, all tables? we have some situations where we had some nested views, like 5-level nested views that I changed to column store indexes, because it takes so long to materialize the view and pull it across. It proved to be much easier to put it into a table, column store table, push that across to the other side, and it can be reported on. Works quite well. So is column store something that is good to work with? The example, the testing I've done has come up with another situation. The server I'm running on has a setting of max.6. It's pulling data from a server with max.4. When I look in query store at the query, it runs it as max.1. Is that something that we know about, or is that just something unusual? I know with statistics, you can have statistics on external tables. You can't update them, so I assume you can drop them, recreate them, because this is what we're doing every week. We're recreating tables and pushing them across. So statistics, is it best to have the accurate statistics on the source, or is it better to have accurate statistics on the external table? Yeah, that's about 6 questions. Any thoughts?
Yeah. So for our live studio audience, let's summarize some of these things. And by the way, if I get anything wrong, let me know. So there is an original source system that is Oracle, right?
Yeah.
And then that data comes over to a SQL Server instance, which you've called S. And then Integration Services moves that over to another SQL Server instance for reporting.
Well, you've missed one piece there, Kevin. It puts it into a database, which is then used in an ETL process to populate another database on that server, and then it uses SSIS to push to another server.
Okay. So in other words, there's this whole chain of projects of process to move data around. Setting the story. So the first question: big tables, small tables. Where does Polybase fit best? Hillary Cotter. Hi. Hello. Query store records data on a query. It is possible the query might use max.1. Yeah, that's a possibility. And as by about question 4, there are a couple of things, because this is Polybase specific, there are a couple of things that may affect that. But large or small, originally, Polybase was designed to work with Hadoop and was intended to query large amounts of data, to process large amounts of data pretty efficiently. And with SQL Server 2019 and that expansion out to other sources, Oracle, other SQL Server instances, Teradata, et cetera, there is a question of how do you differentiate Polybase versus using a linked server. And one of the areas of differentiation is expected number of rows, where if you have relatively small queries, linked servers typically will perform better. The reason for that is linked servers have less processing overhead. The linked server operation is happening within the SQL Server database engine. It is not happening in a separate Polybase data movement service or in a separate Polybase engine. And so there's no need to queue up new operations. There's no need to basically schedule this work to be done. The benefit to the Polybase method of execution is its ability to scale out and to operate on things concurrently, which when you have multiple SQL Server instances, will allow you to attack a problem in parallel in specific circumstances and handle much larger data sets than what you would comfortably do with a linked server. Anders is sassing linked servers, and I can understand that. But that's the general idea. In principle, this is intended for working with larger data sets. There is a startup cost in terms of time. So it's not intended for, I need transactional processing results immediately. Definitely more of analytical processing where I can afford to wait. I don't need millisecond or microsecond response. Like Hillary mentions in here, Polybase is intended for cheap storage. You say I care more about low cost than fast performance. Yeah, that's definitely the case, considering we talk about, the original use case was Hadoop, where you very much were about lower cost versus faster storage, or Azure Blob Storage. Even with other sources, generally the best use cases for Polybase are, I don't need to query this very often, and when I do query it, or if I do query it very often, I can afford to wait on this. This doesn't have to be my transactional system. If you do try to use it as transactional system, you will be disappointed. So typically, larger tables work better, but with smaller tables, the performance is roughly the same as linked servers. Unlike Hadoop, there's not a big startup time. So you're not talking, I have 30 seconds for a yarn job to start. Instead, you're talking more like dozens or hundreds of milliseconds for a job to start up. And at the one row lookup level, that will typically mean that it'll be slower with Polybase versus with linked servers. But that once you start talking 5 million, 10 million rows, usually the Polybase answer will be faster. I have to preface it with usually because that's a lot of it's going to depend on the query and on whether the linked server is able to push down predicates or if the Polybase query is able to push down predicates. They have slightly different rules on how they can push down, and that can affect query performance considerably. So next question was around nested view nastiness, and I will say that when it comes to querying data using Polybase, you want to make your queries as simple as possible. Probably simpler than you would ideally like, because you get this benefit of predicate pushdown under certain circumstances. So, for example, if the data lives in Oracle and I want to query Oracle directly, and maybe I have one table in my SQL Server instance locally that I would like to join to that big table in Oracle. And based on the rows in my SQL Server table, I could filter down to 1% of the data in Oracle. I cannot send data over to Oracle. So with linked servers, this is actually a difference between certain linked server drivers and Polybase. With some linked server operations, like going to another SQL server, you could actually push data over to the remote server, have it do the work. So if you were doing a join between two tables, a huge table and a small table, the driver, the operation could potentially allow you to send data over to the remote side and have execution happen over there, versus with Polybase, there is no send data out to the remote source, except if you're using, no, actually, not even when you're using the original jar file creation for Polybase and against Hadoop. So even then, that's still creating a MapReduce job to work on remote data. It's not sending anything over. And for that reason, anything you have on your local SQL Server instance, if you want to filter down on the remote side, you'll have to make it, I hate to have to say this, but essentially it has to be a static query. Like, for example, let's say that I have a table where I need to get the states associated with the Midwest. We talked about that with weather before. And let's say that actually an example that I used in the book was New York City parking tickets. And if you look at Midwestern states, well, Midwestern states don't typically get too many tickets, like licenses or plates in Midwestern states don't tend to get many tickets in New York City. Not surprisingly, most of them are New York, New Jersey, Pennsylvania, that area. So if you have, I want to look, Ohio, Indiana, Illinois, Minnesota, Wisconsin, et cetera, and if I have all of those states in a table where I can say where region equals Midwest, and that table's in SQL Server, and my raw data is in Oracle, it will not push down a very simple predicate like and state is in OHINIL, yada yada. Instead, I have to create that predicate myself. And you could do that with dynamic SQL to generate the SQL statement that will then execute against that Oracle remote table and push down where state is in OHINIL, yada yada. That will allow the Oracle side, assuming that that table has an appropriate index that includes region or state, that includes state. That will allow the Oracle side to return then the very small number of rows that are associated. If you don't do that, what ends up happening is the Polybase engine asks for all of the data in that table, pulls it locally, probably puts it into a temp table on your Polybase server or servers, and then performs a join. So you're moving all of the data over. That's going to be a lot slower than if you perform the predicate pushdown. I say this, I lay all of this out because the more difficult the query is to optimize for the database engine to understand, the less likely the database engine is to do the right thing. And the more likely it is to say, you know what, forget it. If I pull all of the data over, I know that I can solve this problem. And that's usually not the answer that we want. We typically want, only give me the data that I need and then do the rest of the problem. And as you have more complicated queries on the remote side, especially when they do join to the local side, life will get tougher. If all of your complexity is on the remote side, meaning that, let's say I have 5 or 6 Oracle tables, then in that case, potentially, the optimizer will be smart enough to let Oracle do all of the heavy lifting, do all of that work, and will pass down the predicates appropriately, will allow the Oracle query optimizer to generate its most efficient plan to filter down all of the data and essentially take the results from Oracle and present them to you. If you get unlucky, what'll happen is that SQL Server will say, oh, well, all 5 of these tables are from Oracle, and I'm not exactly sure how to pass down this predicate, so we're just going to pull all of the data from Oracle, put it into a temp table, and then perform the query operation on SQL Server side, and then lose all that data afterwards because it doesn't live here. So
you're talking about Oracle at the moment. If that was just SQL, would it understand the indexing on the source?
The source doesn't necessarily matter in this case. So it could be Oracle, it could be SQL Server, it could be Postgres or MySQL via the ODBC driver. So it's not so much that the Polybase engine innately understands a lot of details about the remote side. Instead, it's more of, can I figure out what this query is asking for and reshape it, translate the query into something that will work on the opposite side, and is that likely to give me, like, do I need to pull back everything or not? So the more complicated things are, the more likely the engine is just to say, forget it, we're doing it here.
So when I define the external table, it just describes the columns. It doesn't describe any indexing structure, correct?
That is correct. All of the indexing stuff is located on the source side. The external table is just a pointer to that location.
So the question I had about statistics, is it, I know you can create them on the external. Is it best to have good statistics on the external or on the source?
Short answer to that is both. So you can create statistics on external tables. And the benefit to that is, again, helping the optimizer figure some things out, helping it have some estimation of just how much data there is to get a feeling for, should I push this down or should I just pull everything back? And if your stats are accurate, you're more likely to get the right answer, especially when you're talking about very large tables. But it's also important to have good statistics on your source side, whether that be Oracle, SQL Server, or whatever else. As long as you have the capability of generating statistics, if that concept makes sense, then just it's a good practice to have those be fresh, up to date, and correct. Not everything in the Polybase world will have stats. So, for example, if I query Azure Blob Storage, there's no statistics there. And there's also no ability to push down. At that point, if I'm querying Azure Blob Storage, I'm just saying, pull back the data from this external table, pull back those blob files, and I'll handle it all here because there's no compute on the other side to do that work for me. So the short answer is, it's good to have accurate statistics on both sides. If you had to choose one, it's probably better to have accurate stats on the source system. If you ignore the stats on the Polybase side, you as a developer can still try to finagle things using, for example, the external pushdown hint. So forcing external pushdown if you can, and writing queries in such a way that you try to simplify the process. You try to give the engine as much as possible the ability to push down whatever operations it can and not get confused with complexities. It also means that as a developer, trying to find ways to deparameterize certain types of queries, where if I have, for example, a stored procedure call and I have my input, that input, because it's a parameterized it's an input parameter, the Polybase engine won't know in the execution plan, do I need to push down or do I not need to push down? And so you may end up with the wrong answer. And there you may say, force external push down, and that could help. Alternatively, for complex scenarios, like I was talking about with region, or if you have the joining of multiple different remote sources, you may want to generate a series of independent dynamic SQL statements and load the data yourself into temp tables and join together at the end. So it's not the ideal world of true data virtualization where I don't care where the source is. Let me just write a single T-SQL statement that happens to join across MongoDB and SQL Server and Oracle and Teradata and Hadoop cluster and blob storage and Spark tables and all of these other things all together. In practice, that query is going to be an absolute dog. As a demo, it looks really cool. And in some cases, you can get away with it, especially if you don't care much about performance. But as soon as you start introducing multiple locations where the data lives, the likelihood of getting a fast result drops precipitously. Because you cannot take, well, I'm going to take this Oracle data, and the elements in this Oracle data will help me filter down the Mongo data, and then the combination of those two is going to help me filter down Teradata. As a human, you could walk through this process and find a way to cut out 95 to 99% of the input data. As a generalized processing engine, this is not going to do that for you. It's going to most likely pull all of the data from all of those sources into temp tables, join them together, filter out, and then give you back the results. And if you've got time for that, if your operations aren't that complex, that's a really cool thing. But it also means that you may be waiting a lot longer than you'd hope.
The execution plan I got was very complicated, confusing. In the end, I had to get Hugo to find the remote call. I expected when I clicked on the external table that it would show the name of the external table, but it doesn't. Somewhere else you've got remote call, but so it was unfortunate. I used too complex a query and to start off to look at this, but for the life of me, I couldn't find where it was actually looking at the data on the source side of things.
Yeah, so in the world of in Polybase, because this goes back to APS or to SQL Server Extremely Expensive Edition, there were a few databases that were created. And actually, SQL Server 2012 and later, you see these databases, and they don't really have much use, like DW configuration. They don't have much use on premises in the Enterprise or Standard Edition, but they were artifacts from the APS edition, the SQL Server hardware, combined with Hadoop. And inside those databases, you'll find information about the external operations themselves. Now, I'd have to pull up the book chapters to figure out exactly where they are again, but I do actually talk about that a little bit, of where you can find information on queries, where you can find the query details. There are some dynamic management views that will help you a little bit, but the raw data on the queries themselves are in tables inside of one of the three databases that get generated. And while I am vamping about this a little bit, let me pull this open and see if I can remember where that was located. So those are Hadoop and blob storage integration errors. Actually, I think I can find it in there. So that's the job tracker. Take a excuse me. So yeah, DM exec compute nodes is going to give you some information about what's running. That's not going to be sufficient. So let me try chapter 10. Chapter 10. That's the one that I was thinking of. Let's see where these live. Sys.external tables, dmexec compute nodes and status, errors and services. Sys.dmexec external work. Yeah, so this is a dynamic management view that returns a row for each of the last 1,000 Polybase queries that have run since the last time the engine started. So that's sys.dmexec external work, which turns into a link here for some reason. And that's going to give you part of the basis for where you can find information. DM exec distributed requests is another useful query because that'll give you one line per distributed operation with a SQL handle. So that query, ooh, that turns out really bad in Twitch chat. But the benefit to that SQL handle is that you can cross-apply it to dmexec SQL text and see the actual SQL statement that ran. And sys.dmexec distributed request steps helps you see what is happening within an individual operation. So what are the individual steps that happened? This was a, for example, round robin operation where that's how we were pulling the data. We have a sort in here. It's sort of the broad version of like what a poly-based execution plan looks like. It's not the same thing as what the database engine shows you, but it's a more detailed understanding of the steps that happen with the Polybase engine and the data movement service. And those will give you some idea of where you're able to query and where you're able to get a little more information on what's actually happening in an individual query. Because if you look at the execution plan, you're right. All it says is remote query, and then that's it. It's a black box at that point.
It took time to find the remote query. Like, it's unfortunate I had quite a complex query, but I found the table that I created defined as external and expected, instead of saying the external name, it said the internal name on the server. So that confused me. It wasn't until later on I posted it to SQL Help, and Hugo picked it up and showed me how to find the remote query part, because I wasn't expecting that. I was expecting to see, yeah, you found this table, but it gave the name of the table that it was on the server, not the external name I'd given it.
Right. Yeah, no, it's you're right. There's a lot of complexity and skullduggery that honestly I think could be simplified and improved. As it is today, if you do want to dig in, the benefit to this approach is it'll work across every source. The downside to it is it's a new set of DMVs, it's a new set of operators, and a new set of operations, all of which are not extremely well documented. So even in that case, there's a lot of guesswork about what exactly is going on with an operation, and if that's a thing that's performing poorly, what can I do to change it? There's very little guidance on that, and I've tried to add what I could, but there's a lot of murkiness involved in working with Polybase operations in production.
Well, now you've told me where to look. I'll take a look at those DMVs and see what it shows me.
Yeah,
But,
and in the book, that's chapter 10.
Yeah, I think what is good, I started this, and then they announced SQL 2022, where you can have a secondary in the cloud. Like, eventually the idea at the university is to move to the cloud. When it will happen, who knows? But in 2022, you can have a secondary, basically what we've got, read only in the cloud, and then that gets by the situation we have. Originally, I thought of using an AG, because you've got the data, you're pushing it to the secondary server, you can have it read only because you're running reporting off it, but the complexity of having an AG, and unfortunately the admin staff I'm working with, I don't think are up to it.
Not all companies can have Tracy.
Yeah. Anyway, you've given me some very good ideas. Some more to look at. If I can figure out why it went max.1 single threaded, then perhaps this isn't the answer.
That's an interesting question. And as far as it goes, polybase queries are not necessarily going to be single-threaded. There is parallelism, which is possible, to my recollection. Now, I'd have to go back through my notes just to make sure, but I believe I remembered seeing parallel queries. What could be happening possibly is something stats related. It could be in the way that the query is written, where it is deciding to take the serial plan. And it could also be that based on the data that a serial plan is the appropriate answer. I guess that would depend on what the remote query looks like.
Well, I tried the same query with a hint max.6, and it still query store still said it used max.1. So maybe I'll get to look at those DMVs you mentioned. That may have something in there too.
Right, and like Andrew says here, sometimes serial plans are the best, and frankly, I bump that up to often serial plans are the best. Even if you specify a query hint of max.6, it may be that the optimizer said, yeah, you're telling me I can go up to 6, but 1 was still the best here.
Well, in my testing, and I clear the buffers, I clear the procedure cache, it took nearly twice as long to look at the external as it did to look at the internal. And that was only changing one 70,000 row table. I tried it later on with a 50 million row table, and it wasn't much different. Both times it seems to come up with maxed up of 1. The two servers, I said, the source is maxed up of 4. It's got 8 processors, but we didn't go with 8. We went with half. And where I'm running the query is maxed up of 6. Again, it's got 12 cores on it, but we decided not to use all of them as the maxed up setting.
Fair enough. Yeah, that's I'm not sure I have an answer right off the top of my head on it. My recollection was that you could get parallelism with queries and polybase, both sides, both on the source system side and on the local system side, where the source system, I would expect parallelism wouldn't even be a factor, that's all the source system's doing. What's happening is that as far as the source system's concerned, you have this request that's coming in. The driver request is coming in. There's a connection that's been made. Here's a SQL query that's been sent over, and I will process this. I don't know or care who made the call and why they made the call and what system they used to make the call. All I know is I got a call. Let me operate on this and then send over data. Now, the reason that things may be slower, so you said that it takes about twice as long. And was the comparison between running the query on the source system itself versus running the query through polybase on the remote system?
What I was doing is on the reporting side, I ran the query, so it's looking at tables on that server. I then created one external table to point to the other server, ran the same query, and it took maybe not twice as long, like 8 minutes to 12 minutes. And later on, I changed. That was with the 70,000 row table. Then I did the same with a 50 million row table. And again, it took much the same time. So I'm calling external tables, and it increased the time. And when I saw the max stop change, I thought maybe that had something to do with the time it was taking.
Gotcha. Yeah. If you tell me that there's a 2x performance difference between local tables versus querying remote tables, wouldn't blink my eyes. That is not that's not ridiculous at all. And there may be not much that you can do about it. Possibly one area where where you could investigate using the DMVs, using the distributor request steps in particular, that'll tell you how many rows are being operated on. So if you see a large number of rows coming to the remote SQL Server instance, that's a lot of network traffic. And that can take time. And the processing happens on the remote system once and then on the source system again. And that can add to the overall time. So that would be an area to investigate. Trying to understand if more rows are coming in than you expect. Like we're doing a full table scan of this remote system and pulling all 30 some or 70 million rows back, or 70,000, however many, and then filtering down to the 1,200 rows that I need here. And this could give you an avenue for at least understanding the reason why you see the time difference. There will be some overhead. It's just, unfortunately, that's built into the engine itself. And even with smaller queries, I do tend to see a substantial enough difference that it's not something I want to use for real time. But you may see that that it will take longer, and kind of the trade-off is this can be a much simpler process if you can afford the extra time.
I think what I will try, instead of a complex query, is a simple query and do the same, like define the external table on that and see. Because I said in this particular case, I didn't realize how complex the query was when I started to use it. So it's a question of, there might be some cases where this has a benefit rather than SSIS it out and screw it up on the side where it's been reported on because it's got a whole bunch of indexes. That's one of the other things I'm attempting to do is the SSIS, if you've got 20 indexes on it, and most of them is supposedly a data warehouse, so the single column indexes, is to actually drop the indexes where we're pushing it to, push the data through SSIS, and then rebuild the indexes at the far end. So they're not disorganized, for one thing, and it seems to balance out in terms of time. So yeah, looking at seeing if polybase work. Maybe there's simple solutions where it's a single query looking at one or maybe two tables and go, yeah, this is a situation where this could work. Anyway, You've given me lots to think about. The new part is being able to find those DMVs so I can see if it knows what it was attempting to do. And I'll go from there and hope I get my hands on 2022 sometime.
Yeah, good luck. And follow up if you run into more issues. But thanks for all of the questions and the free content on Shop Talk tonight.
Well, thank you very much for allowing me to do this.
Of course. And now, let's talk about 2022. So that was announced last week at Ignite. And they've announced a couple of things. And like I mentioned, Ignite is usually where you get I guess I'll call it the business splashy. And later on, you tend to get the really interesting components within SQL Server. Even so, there are a few things of interest that we got. So first, let's talk business splashy. integration with Synapse Link. Today, Synapse Link works with Cosmos DB, and what it does is that it allows you to take a Cosmos DB collection and have sort of an OLAP style view of it within a Synapse dedicated SQL pool. There's a real easy Scala command, so you can work at it. You can work with it from a Spark pool, and then one of the easy things you can do is save the results into a dedicated SQL pool. So it's a way of doing ETL style operations without having to use Azure Data Factory or Synapse pipelines or integration services like components. Well, Synapse Link has also been announced for SQL Server. So on-premises SQL Server, connect to that Azure Synapse Analytics dedicated SQL pool. Probably, my guess would be via Spark pool again, using the SQL Analytics function, and be able to push data into Synapse from on-prem fairly effectively. Andrew says, I'm already trying to convince my company to allow me to EAP it. That would, yeah. They are looking for early access partners. Next one, integration with Azure Purview, which is the new Microsoft service for master data management, data classification, data collection, data understanding, basically. And that one, again, has some good business value. It will allow you, for example, to try to classify what your sources of data are, what your data lineage looks like, how data moves from source to source. I will be interested to see when they say integrate with Purview, just how integrated it is, because there are certain things in Purview where you get full data lineage. You can see that this became this, became this, became this. Other sources in Purview, it's just, well, we can do a quick scan to see if there's something that looks like a social security number. So we'll see what this looks like for SQL Server. Disaster recovery for Azure SQL managed instances. So you could have, I believe the implementation we're talking about is a distributed availability group between on-prem and a Azure SQL managed instance. Do you know any of the details about that, Tracy?
Yeah, you're able to set up availability groups between on-prem and MIs, and then it's a distributed availability group. So then you're able to fill up to the cloud, and the cloud would be 2022, obviously, and on-prem could be any version really, but once you're on the MI, you would be stuck in 2022. And then, as far as I know, we don't know how you would get back down if you're already on 2022 in the cloud, but you can set the distributed AG back up by putting, backups in blob storage and restoring it down to your system and resetting up the distributed AG and then coming back.
Yeah.
But it's a DR scenario that you could set up so that, if your on-premise systems go down in your data center, you can make things run in the cloud.
Yeah, and Anders mentions it's a managed distributed availability group. So
that's a fancy word they're putting on it.
yeah, managed. So, some of the work is managed for you. You don't have to do all of it yourself, I guess. But
I didn't realize they put the fancy word on it.
They're using the M word, meaning you don't have to configure it. Yeah, and obviously you don't have to.
Well, that takes all the fun out of it. Because there's no GUI for configuring a distributed AG.
No, there isn't. I
hope to finish the documentation on
that. Also, ledger tables, which will have about 1% of the use that I think a lot of people will think that they will have. The idea of ledger tables is, I'm not going to use the B word. I'm not using the B word. The idea of ledger tables is I want to have some auditable process that tracks every change to the table over time. And if you just have a table, a DBA could come in and modify this. Even if you break write access for DBAs, if you have sysadmin rights, I can grant myself those rights again and then modify the table. If you write out to an auditing system, I could use the same process and modify the auditing system. Unless you have what is called a warm drive, write once, read many, where those rights are permanent. But if most of the time we don't have that, we just have files that are written to a regular storage system because, well, warm drives tend to be really slow. Like think CDR. That's a classic example of write once, read many. And these are the types of problems that if you have institutional requirements where we have to prove that this has not been modified, that's where a ledger table can be useful, where it's creating hashes of elements that have changed and elements that are still there. I'd have to dive into exactly what the hashing process looks like, but it's creating those hashes and it's writing them to one of a couple of places. And one of those places is an Azure, a write once, read many type of storage account. So they are introducing that for Ledger, because if you just write it to blob storage, well, anybody can modify those blob storage files, and as a result, you don't really have that real scrutinizable process for proving that this was not modified. So that's the benefit of ledger tables. I think they're an interesting idea, especially if you don't use the B word. That rhymes with flock lane, as Mike mentions. If you don't use the B word and you get past the hype, they're interesting. And in some cases, like banking, they can be viable. So I think it's probably worth having. But, like Andrews mentioned, coffin corner cases. Yeah, these are scenarios where 99+% of the time when I think I could use a ledger table here, the real answer is I probably don't need a ledger table here. I'm not going to court to prove the veracity of this data. And if I'm not likely to go to court over this specific data, it's probably not a great answer, because it will take more resources. It will obviously take a lot of disk. If you have a large ledger table, you have a very active, very frequently updated table that has ledger turned on, you're writing all of those changes. I mean, you have to write the changes. You have to write the hashes. You have to write everything that has occurred so that you have the auditable guarantee of this data is as it is, and I can prove that as of this point in time, it looked exactly like this, and that nobody could have changed that after the fact. So, interesting idea. I mean, it's certainly they're taking advantage of the current hype about blockchain, but I'm not sure just how useful it'll be for a lot of cases. Now, things that are going to be useful for a lot of cases. Updates to Query Store. Actually, you know what? I should have done the joke. Last write wins on peer-to-peer replication.
Oh yeah, that one too.
Yeah, I should have landed that. That was the joke that I needed to land on. But
wasn't
actually,
that put in the CU though for 2019?
Yes, it was. And it's also going to be in 2022.
Yeah.
So what's the reason for adding ledger tables if they have such infrequent usage? Large customer paying money, buzzword checkbox, a little bit of both. Because the customers who do need it, like I mentioned, banks, I mean, they're going to throw big money, and there are cases where, yes, certain tables could legitimately be ledger tables, and we do need to track that. Certain other institutions, again, where you need to have a verifiable, auditable process for this data. And in those cases, ledger can make sense. I just think that for the majority of us, the majority of tables, even within those giant financial institutions, most of your tables shouldn't be ledger. So query hints on Query Store. That's one thing that's interesting. Tracy, you were also talking about other Query Store updates.
Yes. Being able to have Query Store on your read-only replicas in AGs. It's nice because my company does a lot, sends all their read-only traffic to the secondaries. And, well, we get crappy plans over there because there's nothing to fix those over there. And you don't want to create all your, stuff everywhere else and you can't get the right plans for us. So now you'll actually be able to use Query Store like you can everywhere else. Isn't that nice? I don't know how they're implementing it because the database is read-only, but I don't care.
Yeah. Andrews asks, does that mean you can now have different indexes on secondaries too? I think the answer is still
Doubtful.
no.
Don't think so.
Yeah, and you could do that with replication, but with availability groups, I mean, the whole idea was this is read-only, like Tracy said.
Yeah, like I said, I don't know how they're doing. I assume it's going to be stored in a system database of some sort. I mean, there's no way they can write it into the database that's over there because it's read-only.
Yeah, Query Store writes to the read-only DB. That may be changing, is the guess. We'll find out more, I'm sure, once the first public previews come out, and someone like Tracy has had a chance to dive in. I say like
I'm
Tracy, it doesn't have to be Tracy.
I'm gonna look. I mean, I'm waiting.
Yep.
Query Store is one of my favorite features.
So we'll have more information about that as the public previews come out, and if history is something to guide us, late this year, early next year. I think when they announced 2016, it was at Summit, and they had the first public preview. When was that? About December, January timeframe?
I want to say so, yeah, because I know we were using the preview in production by March, so
Yeah.
one of the versions was in production. Well, yeah, in production by March. I don't know what version, but.
So Andrews just say, yeah, it's only read-only because they say it's read-only. Like, you can disable CLR, but there's still plenty of CLR code that runs on newer versions of SQL. Right. But that's all system managed as opposed to user code. So, all right. There is still plenty more that I'm sure we'll hear about this upcoming version of SQL Server. They've been working on it for a couple of years, so I'm sure there's a lot more to it than just ledger tables and integration with Azure services. But those are the things that they wanted to highlight at Ignite. As we go through Summit, I would expect that we're going to get some fancy sessions that dive into it. I know Bob Ward's got a session on it at Summit. He's also got one at Live 360 that's next week, where he's going to go into it in more detail. And that's where I would expect that we're going to start seeing all of the interesting things for us, as opposed to the interesting things for the business folks.
Yeah.
So
we gotta spread it out,
That's true. Yeah, you gotta
reel you in.
You gotta make the marketing last as long as possible.
Spread the breadcrumbs and make you come for more.
Exactly. So on that note, we are going to make the marketing last as long as possible by wrapping up for tonight. Thanks for coming by this first day of Past Summit. We will be on the air again. Let's see. Next Tuesday, I'm going to do a presentation on window functions for the main meeting. We will not have an advanced DBA meeting tomorrow night because of Past Summit. And the data science and business intelligence meeting is done until January. So we've wrapped up that part. So basically, one more meeting will be next Tuesday. That'll be our main meeting for the month. We'll have one episode of Shop Talk the week after that. And then I think we're done until we get into December. February is when it's time to take a real look into it. Yeah, that's probably a good idea. The first CTPs will be interesting from the standpoint of I want to try this out, but getting a feeling for what's going to be in the product, that second CTP is usually a really good one.
Yeah, because every now and then they'll take something out because
That is
too
true.
buggy.
Occasionally they will, like SQL Server 2005 and the whole block of stuff that they took out to get it released on time.
Yeah. Plus, it gets less buggy as it goes along. So, and they get newer stuff in there. So,
We hope.
the more they release it.
But all right, everybody, thank you so much for dropping in tonight. And we will see you again, hopefully, sometime soon. Until then, everybody, take care.
Right.